Alright guys, so this is what we did today. Or if you're in my afternoon classes, what you're going to do. Page 178 is going to be the notes, and then 177, which is the front, is going to be the assignment. So you read the story and it says they're going to be bicycling. Charlie's going 15 miles per hour. Eric is going 10 miles per hour. So Charlie gives him a head start. And it tells us to make a table. It already fills out the X and Y axis for us, but it wants us to fill out, labels it for us, fills out the X variables, but we have to do the rest. So I just put 15 miles per hour here so I won't forget that's Charlie, and then that Eric is 10 miles per hour, since that's what the story told us. So we filled out this part first. We said if he is going 0 hours, then he's going to be 0 miles away. So in 1 hour, if he's going 15 miles an hour, he's going 15. In 2 hours, he's now 30 miles away. In 3 hours, he's 45. And in 4 hours, he's 60 miles away. The process, this is our slope or our rate that he's going, is 15 miles per hour. So that's multiplication 15 times the hour, and that's it. So times 0, times 1, times 2, times 3, times 4, and it does make sense because it does gives us 15, 30, 45. We did the same thing for Eric, but Eric has a 15-mile head start that Charlie gave him. So he doesn't start at 0, he starts at 15 because he's 15 miles away. And then after that, he's going 10 miles an hour. So every hour, he's 10 more miles away. So we just added 10 plus 10 plus 10 plus 10. That's how we filled out our table. But our process has to do with our rate of change. He's going 10 miles an hour. So it's 10 miles per hour. But since he has that head start, you have to add that on there. So 10 times 0 is 0 plus 15 is 15. 10 times 1 plus 15 is 25, and so on. So this makes sense. The process makes sense. All right, and then we had to write our equation y equals mx plus b for Charlie. So y equals m, which is our slope, 15 miles per hour, which is our rate. And if it matches our process here, 15 miles per hour, so our x is hours, so 15 times x equals y. Okay, so pretty much the same thing. And then Eric, same thing. He has, but his slope is 10 miles per hour. And you have to put that head start, which ends up being your y-intercept if you graph it. All right, and then the next part, we had to graph it. I asked you guys to do it in different colors. So our x variable, again, is hours. Our y is distance or miles. So we label this x. Since we have such few numbers, I skipped one line and then made this one, skip another one, 2. And then since our values, the highest we're going to go is 60. Well, actually, we want to go higher. But you see it's kind of going by 5s, and that would fit all of them. So I went up every line by 5. That way I was actually able to fit all the way to 100. And that's perfect because the course is 100 miles that he goes. All right, so we started plotting the points. We started with Charlie. Charlie starts at 0, 0, 115, 230, and 345, and 460. Then I just followed, 460. I just followed just the pattern. See how it's going up 3 over 2, up 3 over 2, depending on what your scale is. So I just followed it, extended the line. Same thing with Eric. Eric, we started with 0, 15, 125, and 235. So we plotted the points we had. It stops here at 4. So from here at 4, I just followed the same pattern that I was seeing. According to my scale, it's going up 2 over 1, up 2 over 2, up 2 over 2. And I just kept going until I got to the end. All right, now the slope is still 10, just because he's going up from here to here. It's going up from 15 to 25 is going up 10 over 1. See, if you go by your scale. So the slope is 10, but I was just going by the boxes so I can extend it. Then we answered some questions. How far has Charlie traveled in 4 hours? Well, I can get that information from my table, or I can get it from my graph. 4 hours. Charlie is my green line, so 60. Next question, how far has Eric traveled in 5 hours? So I can go from my graph, since I did extend it, 5, and go to Eric, and then see that he's 65 miles away. Or I could extend my table, since I can go up one more, and this was going up by 10, so 55 plus 10 would be 65. So that was another way I could have done it. When does Charlie catch up to Eric? Well, he catches up at 3 hours. That's exactly where they meet up. They share the same point, 3 hours. They're both 45 miles away. So in 3 hours, they're both 45 miles away in the course. So that was our answer. Then how long will it take Eric to go 50 miles? So Eric, 50 miles. So 50 miles is here. Go all the way to Eric. This is where it meets the line. Go down, and it's right between 3 and 4. So it's 3.5. To be exact, and just to check it out, we use the equation for Eric. We substitute 50 in place of y, since it's distance. Solve for x. So we subtracted a 15, subtract a 15. That gave us 35 equals 10x. Then we got rid of the 10 by dividing by 10. Divide by 10. So that gives us 3.5. So just double checking that it was 3.5. And the last says, who will finish the course first? Well, you can see that that Charlie starts off lower at 0, 0. But because the line is steeper, he is faster. And here they switch. Here, Charlie is below Eric. So he's still behind. And Eric is ahead. And then here, they actually switch. And now Eric is below, the line below Charlie. So that means that he is slower, or he is also further away. And Charlie is closer to the end of the course. All right, backside is your assignment. Pretty much same thing, except a different story.